it's my pleasure to have a lecture to you guys. So I'd like to talk about the smart mobility at KAIST, and then I'd like to introduce what is smart mobility and how you guys can study about the smart mobility from this seminar. Okay. It doesn't work. Okay. Okay. The content is consists of as follows, and then introduction and smart mobility and my current research. So first of all, I'd like to introduce myself briefly. So just 5 minutes. So I have my research field is about the of smart transportation planning and smart mobility, urban science, and bus and behavioral analysis. So I just become 30 papers published, and then 10 papers under review, and then 7 papers in writing. So maybe it's gonna be about 50, yes, very soon. Yeah, so SCI and SSCI papers, and also have a KCI paper. 16 papers has been published. And then I also have 4 registered patents. And my awards, I have a Minister's Award and number 3307 from MOLIT, government. Yeah, so. And then I have the conferences attendance experiences about 55 presentations. And then annually I attend the international conferences about more than 3 times. And then the domestic conferences more than 4 times annually. So and I also have the project experiences and grants, and then I have about 80 projects has been conducted, and then so that's it. So and then I got a bachelor from Hongik University. So it's my honor to my mother university become a mother professor in my mother university. So I graduated from Hongik University in 2011, and then I graduated from Seoul National University, and I got the PhD in 2018. After that, I worked for Seoul National University for 2 years, and then I have been Georgia Tech for 2 years in Atlanta. And then as I said, I have the research professor experience in University of Seoul. So this is my professional project. It's like a service project from City of Seoul or main governments, and then other research institute. And I also have an academic project for Sejong. First, I'd like to say about the Sejong Research Fellowship, as I conducting this project right now. Yes, so. Okay, so smart mobility is my main research and then teaching and project issues. And so the smart mobility technologies, I intended to investigate the potentials of smart technologies to explore the behavioral characteristics and elaborate the environmental impacts. So I mainly focused on the research related to smart mobility and public transit and environmental impacts, and also have the project related to those kinds of things. And I also have the experience of the two experiences, so IPACS program and ME4 and BCM program. And I'm teaching for the transportation planning and travel behavior. So how do you think about the smart mobility at first? Do you know how, can you guys explain the how do you define the smart mobility? Can you raise your hand, please? No? No one? Okay. Thank you. Smart mobility in smart transport. So delivering the increased user convenience, right? So in a faster and more simplified way, right? So there's 2 words. So the first one is smart, and the second one is mobility. The smart, literally smart means intelligent and fashionable and quick. And the other word is mobility. So we have to think about the passenger and user. So in mobility services, there is passengers. Passengers are passive in the public transit. The vehicle comes to the bus stops or stations, and then the passengers take the bus or subways, right? So that is passenger. But on the other hand, users are the subjective in mobility services. So you can think about the taxi service, Kakao Taxi. So you can just stay in your home, and then you can bring the taxi in front of your home, right? So it can be a user in mobility services. So smart mobility means the integrated user-oriented transport system and the services using the innovative technologies. So you guys can use applications, right? So you can use the application, and then from the application you can call the taxi or other services, and then you can use it. So you guys can be the user in the smart mobility services. So I think I have to say, you have to say after that you can say what is if someone asks you what is smart mobility, then you can say you should say the smart mobility means the passengers make users in the mobility system. So there is a smart mobility. So I'd like to enhance these words so you can understand this smart mobility means. So on the next page, okay. I show you this video. It's from Arab company. It's from about the smart mobility. So just listen to this video.
Smart mobility is all about making transport networks more efficient, safer, and more sustainable.
We have a lot of systems deployed and they may use different technologies, but it's actually been able to bring them together so that we can provide holistic journey information from end to end.
The goal of One Transport is to develop a federated, open marketplace for data assets and data products for the transport industry. What we're trying to do here is change the world a little bit.
The first thing is being able to understand what data we have, how we might open that up in a common way so that others can use that data and provide services.
Technology needs to be sourced from a number of different areas. Lots of people have data that's all over the place, and people need to be much more able to bring that together.
The data may be something as simple as traffic signal timings, it may well be how many vehicles are on a road, but it will also look at what technology is working, what isn't working.
Quality will be really important to ensure that if you're relying on a certain feed, that feed of information is real-time and is accurate.
I think what interested us was the open data element and being able to use our transport information in a smarter way.
It's a whole new generation of predictive, seamless application experiences that take the transport experience that you have today to the next level.
Is to try and help people make more informed choices about how and where they travel using real-time information.
One we often describe is the notion of waking up in the morning and looking at your phone, and your phone tells you to go back to sleep because there's really no point in getting up and driving your car. You're better off getting up, walking to the train station and taking the train. That's the fastest way to get to work.
What we're very interested in is opening up the market so that the end users, whether that be the traveller or the transport operator, can get more benefit than what it currently has been doing.
Through technology, we're hoping that the private market would be stimulated in a way that through the data that we're generating through the One Transport platform, they will see potential.
We're moving from a very siloed world into a much more open world.
There are things that will happen over the next 5 years that we'll never have forecast to happen.
Nobody can predict the future, but at least you can start thinking about the future and thinking about those things that are most likely to happen.
It's a really exciting time how we can turn intelligent transport systems to deliver smart mobility services for customers.
Did you guys catch which word was frequently mentioned in this video? Yes, data. Yeah. Actually, from the video, the data is very important in smart mobility services because we have to give the users about the information of the transportation or transport mobility services, and then they get the information and then they can use the information. And then we have to produce other types of transportation services or information so we can apply the information and make another services or other kinds of information. So that is very important thing. So you guys have to think about the data in smart mobility services. So the next page. So I'd like to introduce my smart mobility studies from this these pages. So all types of mobility or travel mode are available to the smart mobility by adopting the smart technologies. So I'd like to introduce about the smart mobility, except for the autonomous vehicle. Most of people would think about the smart mobility. They would say smart mobility is just from the autonomous vehicle. But without the autonomous vehicle, I'd like to discuss about the shared mobility, including walking. Okay, so there are 5 mobility services: walking, personal mobility, and public transit, mass, and even urban air mobility. So I'd like to introduce my studies and then how you guys can choose your paper subject. So from this seminar, you can think about your research proposal or subject. Okay. The first one. How do you make smart and safe walking? From this video, you can identify the people, right? So we can identify people by watch this video, and then we have to make the computer identify which is a pedestrian and which is vehicle. So from this video, we check the pedestrian from the video, and we check the vehicle in this moment, and then the next one. There is crosswalk, and then there is pedestrians, and there is a bus, and we can identify their velocity of the pedestrians, and then we can identify the velocity for vehicles, and then we can calculate the distance from the pedestrian to vehicle, so we can identify how the pedestrians are in danger. So after that, we can check the situation at first, and then from the image processing, we can identify the pedestrian and where is the vehicle and how the vehicle's velocity is, and then we can announce the pedestrians go faster out, or extend the green signal. So from this research, we can pedestrian safety guidance programs for emergency technology to announce the emergency alarm, or by identifying the vulnerable walkers, or using deep learning process. So this can make the smart and safe walking from the image processing, and then using the AI techniques. And then the next one is a personal mobility. In the mass system or smart mobility system, we have to connect the public transit and the first and last mile travel. So you guys already know about the bike sharing system. Actually, in Seoul, there is a Dani. Dani is a shared bicycle system in Seoul. So it has been established the city of Seoul, and to support the first and last mile travels. So connecting the public transit. So we use the bike sharing data from city of Seoul. So we can make the route from the data. So it's a dot it's a point. Each point by 1 minute. So you can identify their routes, and then you can match the road network system, and then we can identify and road environmental characteristics. So from this process, we made the program, visual aid program. You can see this one. This is most frequently used the bike sharing system. And so here is Hongik University, and the Hongik University station. So this is most frequently used. The bike sharing users most frequently use this area to approach the Hongik University station. So we make the visual aid program by which station where are they from the one station to Hongik University station, and you can identify how many users are in this system. So this is for user aid program, and then we made it And using this process, we made many kinds of papers like this. And the next one, we also have the public transit data, which is smart car data. So you guys already know about the smart car data. So and then we have to improve the public transit system, even though there are so many bus lines and then subway lines in Seoul, right? So more than 300 lines, more than 300 bus stations, bus stops in Seoul, and then more than 700 stations or subway stations in Seoul. Nevertheless, we have to improve this public transit system in Seoul because there is some inefficient routes or bus lines in the Seoul, and then we have to improve the bus system. So we would like to apply the square bus, which is called in Korean daramji bus. So it's square bus. The bus round trip is about 3 hours. One bus line's round trip is about 3 hours, but there is most frequently, there is most a crowded section in the routes, right? So from the crowded sections, we can operate the square bus, like a short route bus. So short route bus, we can input all types of the bus lines in the system, in the road network, and then we can identify which is origin and which is destination. So from this study, we use the genetic algorithm to solve the points, start points and end points. So from the short bus lines is operate to short the line round trips, more less than 40 minutes for the crowded sections. And then the other one is express bus services. So even though there are so many bus lines, we can connect the origin to destination far away from the origin to the destination. So we can make the express bus services in the Seoul City of Seoul networks. So there is there is most frequent travelers in some origin to destination. So from the data, we can identify the express bus service in City of Seoul. So we made we use the After we are using the smart car data, so we have so many papers from this project. And there is another one, is a smart mobility for the mass system, considering user preferences. So in mass system, there is a very important thing. How do you think about the mass system? Mass system has to be two factors. So first one is a seamlessness. So every mode have to connect to each other, and then there is those needs to be seamlessness, because they do not want to wait the other vehicle or during the transport, and then they don't want to take other times for waiting or transport time. So there is very important thing for in smart system. So the process of smart mobile servicing, this process is about from the origin to destination, we can make the journey, and then we can offer the journey to the user. So from this project, we made an application using the user preferences, and then user preferences smart mobile services. So this is a personalized smart mobile services. We have to consider the user has the driver license or not, or they don't want to pay more money or not, or they just want to use the other kinds of services like bike sharing or personal mobility, and so on. So we have to identify the user what they want. So from the survey from this before this application, so from the survey we can get the user's information or user's preferences at first, and then we can make the user optimized route or mode or route services. So user customized mass-based transportation service implemented the plan. So from this project, we can identify how they work, and then how they want to go with some travel mode or travel routes. And the next page. So have heard about this urban air mobility, right? So it's very important thing in Korea. Actually, there is three main projects in Korea. The first one is autonomous vehicle, and the second one is environmentally friendly vehicle. It's like electric vehicle, and the third one is urban air mobility. It's very important. There are three important projects in Korea. So we have to identify how the network are made, and then how the travelers would choose the urban air mobility system after introduction of this system. So if exploring the mode choice behaviors and after introduction of the emerging technology of urban air mobility as an alternative travel mode. So we conducted a survey of the urban air mobility and current travel mode. So you guys can choose I would like to ask, if you guys choose some travel modes such as autonomous, so auto or public transit, and then you can there is an alternative for urban air mobility system. But you guys don't know about the urban air mobility because there is no vehicle and there is no experiences about the for these urban air mobility services. So we just have to explain what is this service at first, and then we give some information about the travel time or travel cost, and you can compare the travel time and cost from the current travel mode and then the alternative travel mode. So from this process, we can identify how the travel demand has been is going to be about. So from this in this Seoul metropolitan area, we identify the travel demand in this network, and then for two kinds of things. So from this urban air mobility network in the Seoul metropolitan area, we identify how many travel demand is going to be. So from this project, we identify the travel demand. And the next one, imagine this one. You guys can take the small subway lines. Actually, as I said, there's about 13 subway lines, more than 30 subway lines in Seoul metropolitan area. So, and then there is a peak period and non-peak period, right? So during the non-peak period, we can operate the logistics system using the subway networks, right? Because there is so many subway lines in Seoul metropolitan area. So we use the smart logistics using urban subway networks. So we elaborate the air pollution on urban transport network. We determine the optimal locations of subway stations. So we have to determine which stations are suitable for this system. So we use the genetic algorithm because there are more than, I said, there is more than 700 subway stations in Seoul metropolitan area. So we have to choose 1 and 2 or 3 or 4 or 5 stations to operate this system. So we have to, and then there is current system, which is by the freight truck from the main hub to sub hub, and then the final destination using the truck. But from this project, we can change the hub to the subway terminal, and then the subway station and the final destination. So there is no use of the truck in this process. We just use a subway vehicle from this process, and then we have to compare the current the freight on transit cost for using this subway vehicle, and then this is a road delivery cost So we have to compare the travel cost between the this system or this system. So if we want to apply this freight on transit system, it has to be less cost than the previous system, because already there are many freight system using the truck system in this system, and then we have if we want to apply this system, we have to it has to be less cost. It has to be minimize the cost. So from this project, we have to compare the current truck delivery system and then the subway delivery system cost. So smart logistics system has the benefit for reduction of air pollution by substituting the ground traffic to underground traffic operated by electricity. So there is very important thing, and now I'm working for this project as well. So it's going to be, I'm making the paper right now, and then it's going to be published soon. Okay. And next, I would like to introduce about the current research project. The first one is autonomous vehicle load in a city of Seoul network. Have you ever taken the which one is that? Vegas loop before? No? Actually, I have taken the Vegas loop before 2 years ago. Actually, there is like a cave, right? So there's like a cave here. So and then the autonomous vehicle goes in the cave and then moves to other destination. So it's like very tight cave. So it's gonna be some scared, because if there is a fire, you're gonna die. There is no chance. Okay? Yeah. So it's very scared system. But we have to think about how we make the autonomous vehicle network design from this one. So after the development of the autonomous vehicle, and then we have with the autonomous vehicle load, we'll be able to support the short and long distance travels in urban network. And because there is very high cost in building the road in city of Seoul area, because there's the estate cost is very high. So we have to think about the underneath autonomous vehicle network in Seoul, because there is no rent anymore for the road. So we have to think about the network here. So there is the borderline of the city of Seoul. So what we make some lines here. So autonomous vehicle line is underneath more than 40 meters underneath. So we can make some network here, and then we analyze the travel demand from the city of Seoul area. So we also have to think about the route choice model or mode choice model from here, because someone would like to choose the autonomous vehicle, but the other one was don't want to take the autonomous vehicle in the city of Seoul area. So we conducted the city preference survey from this project, and then it's going to be almost it is minor revision process for now, and then it's going to be published soon. So this is the autonomous vehicle load network in the Seoul area, and then since the travel demand of autonomous vehicle load network in the city of Seoul will be increased more than 15,000 vehicles per link per 1 day. So it's necessary to prepare for the needs of autonomous vehicle in city of Seoul area. The next one is about the grant project. So it's a smart mode with AI incorporating latent preferences. So the research method is building the individual transportation demand forecast model, and then analyzing the behavior using activity-based techniques. So as you guys know, in transportation planning, there is 4-step demand forecasting model, right? Yeah, four-step demand forecast model. But we have to change, there is a pros and cons because it's an integrated model. So we can identify the total, how they work in the total network, and then how it works in the network. And then there is some cons because in four-step demand forecasting model, there's the third part is about the mode choice model. So in mode choice model, they don't consider the other travel mode, which is connected mode, right? Such as mass. So we can make the model using the public transit connected to bike sharing or personal mobility in four-step demand forecasting model. And so we have to change the other types of model. There is an agent-based modeling. The agent-based modeling is about the individual travel behavior. So we identify we make the model using this using the individually how they individually travel for their destination in this process, and implemented the verifications of the smart mobility service reflecting the individual preference using deep learning techniques. So there is one of the benefits, as I said before, that overcoming the limitations of existing four-step demand forecasting model and simulating the reality through the activity-based model. And then application of activity-based demand forecasting model for future mobility services. So there is some process here. And then the next one is about the bike sharing demand, incorporating spatial machine learning technique approaches. So in this process, in this project, we have the bike sharing demand from one station to other destination stations. So there is a bike sharing demand in the city of Seoul area, and we also have the travel demand, and we also have the some geographic information on the city of Seoul area. So we identify the spatial impact of using the multi-scale geographically weighted regression, which is MGWR. So it's a very popular model in GIS parts. So, and then I also use the machine learning techniques such as XGBoost model. So strengthening the connectivity with the public transit and estimating the real location routes and to mitigate the demand and supply imbalances. Because as you guys know, there is bike sharing system, and there is stations. And in some cases, there is no bike on the bike stations, right? Bike sharing stations. And then, so we have to move the vacant bike sharing stations. So there is a very important thing is demand and supply imbalance for in city of Seoul area, because from my house or my apartment, we have to take the bike sharing and then to go to the station, subway station, right? So the most vehicle is going to be moved to there, right? So we have to move the vehicle, bicycle, move to other, or take it back. So we have to mitigate the demand and supply imbalances from this project. So there is some impact of the some variables impacting the travel demand for this process, and then this paper is going to be, it's being. I already submitted some journal, but I has rejected. So I have submitted again. It's a bad thing. Okay, the last one is demand responsive transport services. You guys know about the demand response transport service, right? So actually, demand response transport service is different from the taxi service, right? Because there is a 1-to-1 services in taxi service, right? But the demand responsive transport service is 1-to-N services. So we have to get the passenger from one area and then to other area, and then moved them for to the destination, right? So we have to rebalance the vehicle for the most frequently generated the travel demand area. So from this process, we have to move the vehicle some spots to other spots to meet the travel demand and the network. So we have used the deep reinforcement learning process in this process. So there's ICT advancement has enabled mobility on demand services to emerge as a popular mode of travel. So in this network system, there is a framework of deep queue network system here. So there is a quarantine environment, and then there is state, and there goes the queue network here, and then there is a they calculate some categorized system or situations here, and then there's target network. We can check the target network and queue network and same or not, or how they work from this one. And then we can, there's action value and target value, and then we have the some replay the memory here, and then we store this one, and then action here. So in deep learning process, we have the action and agent, and the reward and state and environment. So we made this system using the reinforcement learning based approach here, and then we also compared with the heuristic algorithm here. So it's called insertion heuristic. So insertion heuristic is about we can make numerous schedule to meet the travel demand for some travelers and for other travelers. So from the heuristic method, there is some time-consuming process where the calculation time is high, but in reinforcement learning process, the calculation time is very low. So it's very efficient model from this result. So this is a demand response transport services, and we have already almost finished writing the paper, and then we are going to submit the paper sooner. So this is the last one, and thank you for listening to my presentation, and please ask me anything you want. Okay, thank you.